7.3 is all about complex numbers and how to add, subtract, multiply these numbers together. And before we kind of get into it, though, I want to explain a little bit about how this is going to be related to our next topic, which is going to be quadratic equations. If I have a quadratic equation that looks like this, and later we'll talk about these ideas of roots, zeros, like where it crosses the x-axis, but if it does not cross the x-axis, then it has what we call imaginary roots, and that deals with imaginary numbers. If you remember, I is equal to the square root of -1, and I squared is equal to -1. These two pieces we looked at in the radical section. These two pieces are going to come in handy when talking about complex numbers. So that means when I have something like this that doesn't cross the x-axis, there's no roots, there's no real roots. However, we'll get answers that involve imaginary numbers or imaginary roots. And so we're going to take those ideas and we're going to kind of talk about what complex numbers are in general. A complex number is written like this: A plus or minus, could be either one, B, I. Okay, A plus or minus BI. Now, if I look at some examples that we had before, like -7, negative on the inside, so this could really be written as -1 times the square root of 7, which would be I. This is I, and this is the square root of 7, so I square roots of 7. This is the B part, and the A part in this case is 0. So if I wrote this as a complex number, it would be 0 plus I square root of 7. So this is the full complex number. This is the imaginary number. So every single number that you know, that I know, anybody knows, can be written as a complex number. For example, 3. That's a complex number, but we just don't write plus 0i. So the 0i is left off because there is no I, so it's just a real number, but it's also complex if I think about it as 3 plus 0i. So I want to look at some examples of just kind of solving these things real quick. One of the ones that the book has is the square root of -16. Well, I know that I can rewrite this like I did up here. The square root of -1, the square root of 16. We can multiply those together. Well, what's the square root of -1? I. Oh, that's nice. And what's the square root of 16? 4. So 4i. So anytime I have a negative inside, I can make it I on the outside. So let's do one more. How about the square root of -50? Well, 50 is 2 times 25. So I have the square root of -1 times the square root of 2 times the square root of 25. I just broke 50 down into 2 and 25. Well, what's the square root of 25? 5. What's the square root of -1? I. What's the square root of 2? I don't know, so it's just the square root of 2. So here's the imaginary number. Now, what if I wrote this imaginary number as a complex number? It would be 0 plus 5i square roots of 2. Okay, so this is just kind of an intro into complex numbers. Okay, now what I want to do with these two is I want to look at the idea of adding and subtracting complex numbers. So you notice, here's my A minus BI, A plus BI. So just like polynomials, where we would drop the parentheses if it was a positive, and then add like terms, we're going to do the same thing. So 8 and, I'll drop the parentheses first. Okay, now I just add like terms. 8 plus 6, 14. Minus 3 and positive 5 is positive 2i. So I added like terms. And that's all you have to do for addition and subtraction of complex numbers, is add like terms. So let's look at subtraction. The first step for subtraction when we have polynomials like this is always to distribute. So I need to distribute the negative and drop the parentheses. So 5 minus 6i, negative 7, positive 8i. Now I just combine like terms. 5 minus 7, negative 2, negative 6 and positive 8, positive 2. So once again, this is exactly the same as if we were adding the polynomials, or we just combine like terms. Okay, so adding and subtracting complex numbers is as simple as adding and combining like terms. So the first thing that I want to bring to your attention is when we were doing radicals and we were multiplying something like the square root of 3 times the square root of 5, we got the square root of 15. And I would be tempted to say that the square root of 3 times the square root of, the square root of negative 3 times the square root of negative 5 is also the square root of 15. However, because these are non-real numbers, right, they're imaginary because they have this negative inside, we can't quite do it that way. We have to take into account the negative 1. So this is really the square root of negative 1 times the square root of 3 times the square root of negative 1 times the square root of 5. Okay, what is this piece? What is this piece? They are both I. So that's I times I, square root of 3, square root of 5. Well, what's I times I? That's I squared. 3 times 5, the square root of 15. Now, what is I squared? Well, I squared would be I times I, which is the square root of root 1 times the square root of 1. So it's negative 1. And so the square root of negative 3 times the square root of negative 5 is actually negative square root of 15. So we have to be careful. We have to keep this in mind. We can't quite use the same rules that we did with radicals to just combine the inside. We have to think about how to take those outside first. So that's kind of the first thing to remember with multiplication. So let's look at another example of multiplication and just kind of see what we can do. What about something like 3 square root of negative 2 times 4 square root of 5? Okay, well, we multiply the outsides together first. Outside times outside, 12. Now, what is this? Oh, that's the square root of negative 1 times the square root of 2. And what's left? Times the square root of 5. Okay, so I'm just breaking these things apart, putting them all there. So I still have the 12. What's the square root of negative 1? Well, that's I. And then square root of 2 times the square root of 5, square root of 10. So I'm still keeping this idea of outside and inside, but I'm breaking these apart to get that negative piece outside and turn it into an I. So that's important to keep into mind, because now I want to take this same thing that we've been doing and apply it to double distribution or distribution over multiple pieces. Okay, so before, with polynomials, we did adding polynomials and then we did multiplying polynomials. So the same thing here, we did adding and subtracting. Now we're going to multiply those double pieces together. So something like 3 minus 2i times 3 plus 7i. Okay, so I'm multiplying two complex numbers together. Well, it's the same. I still have to do double distribution. So 3 times 3 9. 3 times 7i, 21i. Negative 2i times 3, negative 6i. Negative 2i times, negative 2i times 7i is negative 14. But what is I times I? I squared. Okay, so now we have to combine like terms. So these two pieces going to combine, and we get 9 plus what? 21 minus 6 is 15. Now, what is I squared? Remember this. I squared is always negative 1. So what's negative 14 times negative 1? Positive 14. Now I have like terms again here. So that would be 23 plus 15i. So every time you see I squared, you need to multiply negative 1 times whatever that I squared is attached to. Every single time. So let's do this again. We have 6 minus 5i plus or times 4, minus 7i again. Okay, so first times first, 24. First times last, negative 42i. Last times first, negative 5 and positive 4 is negative 20i. Now, once again, we have negative times negative is positive 35. But I times I is I squared. What is I squared? Negative 1. Okay, so I have these two put together. So that's negative 62i. I still have 24 here. Here, I now have negative 35. Why is it negative 35? Because 35 times negative 1 is negative 35. Last step, 24 minus 35, negative 11 minus 62i. Okay? Now, the last thing I want to look at is complex conjugate. So we had before conjugate where I said like A minus B, the conjugate would be A plus B. Well, nothing really changes here. A minus BI, A plus BI. Those are conjugate of each other. So in other words, if I multiply these two things together, the middle pieces are going to cancel. That's what we want. That's what we're trying to do. So if I say 3 minus 2i, and I say, what's the conjugate, what's the complex conjugate of this piece? You would say, well, 3 plus 2i. Okay, and just to verify that all of these things work out really nicely, let's see what happens. 3 times 3, 9. 3 times 2, positive 6i. Negative 2 times 3 is negative 6i. Negative 2 times 2 is negative 4. I times I squared. Okay, what happens to the middle two? They cancel. What is I squared? Negative 1. What's negative 1 times 4? Positive 4. And so our answer is just a number. So anytime we have the complex conjugate being multiplied, you should always get a real number. So no i's, no imaginary pieces, just a real number. So anytime we're multiplying a complex number by its complex conjugate, we'll get a real solution. So let's try one more time, something more simple, maybe even. How about negative 7i times 7i? Well, negative 7 times 7 is negative 49. I times I is I squared. Well, I squared is -1. Interesting. -1 times 49 is 49. Is this a real number? Yes, it's a real number. And so every single time we multiply a complex number by its conjugate, it will give us a whole, well, it may not be a whole number, sorry, but it will give us a real number. And so that's it for complex numbers, adding, subtracting, multiplying. And like I said, in the next couple of sections, we're going to begin to talk about quadratic functions. And some of our answers, some of our roots or solutions will be imaginary. And so we'll have to take that into account as we look at some of our functions.